All right, I've got a polygon right here. How many sides? 1, 2, 3, 4, 5. So that's a five-sided. So it's a pentagon, right? So what I'm going to do is this. We're going to talk about this word, and the word is diagonal. Now, diagonal can mean a lot of things, but in geometry, it means this. It means if I start at a vertex and I connect. Now, listen to the wording. They call it non-consecutive vertices. Non-consecutive. Consecutive would mean one right after the other. So non-consecutive would means you are not going to go one right after the other. All right? So watch. This would be a consecutive vertex to this one right here. Do you see that? And this one right here would be a consecutive vertex to this. But if I connect non-consecutive vertices, then I've got diagonals. So if I start from this one vertex, I could start at any of those vertices. I just chose this one right here to start. Okay? If I connect to this non-consecutive vertex, and then I connected to this non-consecutive vertex, are there any others that I can connect to? No, because that would be consecutive, and that would be consecutive. These are non-consecutive vertices. So that's what we talk about when we talk about a diagonal. Everybody okay with that? All right, so that's a diagonal. That's all I want you to know about that. But we're going to do some things with diagonals. All right, so let's do this. Let's just hang on to that. Actually, let's make that a little smaller, like that. That. Okay, and we'll just get rid of it. Okay, watch this. Let's bring that up here. Let's bring this. I'll tell you what, I'm just going to draw my own. Let's just draw my own. I'm going to draw a four-sided figure. 1, 2. Let's go like this. Trying to purposely not make it into a rectangle or a square. Alright, so let's push this over, push this over. So I've got 3 sides, I got 4 sides. Okay, there's my 5-sided that I drew earlier. And you want to do a 6-sided one? Okay, so let's go 1, 2, oopsie daisy. Let's see, 3, 4, 5, and 6. Okay, there's a hexagon. You wanted a hexagon. There's a hexagon. Now it's not a perfect, nice, pretty hexagon like you might be used to. We'll talk about nice, pretty, perfect hexagons in a second. All right, so here we go. We've got our figures. That's good enough for right now. What I want to do is this. Now I'll show you. You'll see why we're going to do this in a minute. Right here we have how many sides in this triangle right here? 3 sides. Okay. Now, can I draw any diagonals on this? No, because if I start at this vertex and I go to here, that would be consecutive vertex. All these vertices are consecutive, aren't they? I can't like skip one and get to the next one because then look, this one's right next to this one. So I can't really draw any diagonals. But there are 3 sides to this triangle. Let me. What do I want to do here? Yeah, let's do this. Let's scooch this down a little bit. And watch. So I've got 1 triangle, and I got 3 sides. Everybody with me? And how many diagonals do I have? 0. I have 0 diagonals. Okay, so we won't worry about. I'm not even going to write that down right now. Look at this. Let's. Are there 2 diagonals? There are. If I start from one vertex, I got to start from the same vertex. It doesn't matter which one I start. I can start at, I don't care what vertex I start at. It doesn't make any difference. How many diagonals am I going to get? 2?
Well, you can start from the other vertex also.
No, I'm saying you pick one vertex. You got to pick one vertex. I don't care which one you pick, but you only can choose one vertex. So how many diagonals can you draw from one particular vertex? Only 1 diagonal, right? You follow me on that? Okay, does that make sense? So watch what we have now. Now, how many triangles did I form after drawing that diagonal?
2.
I've got 2. I've got 1 here and I've got 2 here. Okay, so I've got. I should have switched this around. I should have gone 3 sides, 1 triangle. So let me actually do that. Let's do this. Let's grab this. Sorry, I'm just trying to be a little bit particular here because I want to do the same thing for all the other ones. So I got 3 sides and I got 1 triangle. How many sides do I have here? I have 4 sides, right? It's a quadrilateral. Okay, so I've got 4 sides. How many triangles do I have? 2 triangles. Okay, I want to establish a little pattern here, and you'll see it pretty quick. Let's pick, instead of always picking this top vertex, it doesn't matter. Let's bottom left. Okay, bottom left. Let's figure out all the diagonals from this vertex. So there's 1, and then I go to here. That would be a non-consecutive vertex or vertex. That would be 2. Can I draw any more?
Nope.
That's it. So how many triangles do I have now? I got 1. I got 2. I've got 3. Agreed?
Yes, sir.
So how many sides? 5 sides. It's a pentagon. And how many triangles do I have here?
3.
3. Oops. Triangles. Okay. So one more time, just to establish the pattern. And I think you might see the pattern already. I don't know. Where do you want to start? Let's start down here at the bottom. Okay. And let's go. There's 1. There's 2. And there's 3. Okay. Let's count up how many triangles we have. There's 1. There's 2. There's 3. And there's 4 triangles. Okay. So there's 6 sides. And I think we've done enough to establish this pattern, don't you? And there are 4 triangles. Okay, what if I said that there were n number of sides, n representing any number of sides that you want, okay? If you had n number of sides, how many triangles would there be if there was n number of sides? Matt, what do you think?
N minus 2.
N minus 2, very good, because look what we did. 3 sides, 1 triangle. You took 2 away, didn't you? 4 sides, 2 triangles. You took 2 away from 4. 2 away from 5, 2 away from 6. You get it? Do you get how many triangles you have? So if there were n number of sides, there would be n minus 2 what? Triangles. You with me? Why do we even care about that? Because this is what we're doing in this lesson. We're trying to find the sum of the angles of the polygon. Now we already know the sum of the angles of a triangle. We learned that a while back. What are the sum of the angles? If I added up this, this, and this. 180, right? So there's 1 triangle, so it's 1 times 180 degrees. Agreed? And that's 180. So 1 triangle, you have 180 degrees. This is what we're trying to do. We're trying to find the sum, let's do this, of these angles. We call them the interior angles. So the sum of the interior angles of a polygon. That's what we're finding. That means we're adding up all the angles and seeing what they add up to be. Okay, look at this one right here. How many sides do we have? 4 sides. Okay, there's 2 triangles, so it's 2 times what? Right, because if there's 2 triangles, each triangle is 180 degrees, isn't it? So if I have 2 triangles in there, then I go 2 times 180. How many degrees altogether? 360 degrees. That means this angle, this one, this one, this one are all going to add up to 360. Now I put those little arcs there. That doesn't mean that all those angles are equal to each other. You follow me? I just did that just to show you the 4 angles here. So if I added up the 4 angles, I get 360. What about this? I got 5 sides, so how do I find the sum of all the interior angles? I take 5 minus 2, which is 3, and then I go 3 times what? 180. What's 3 times 180? I think it's 540, isn't it? Okay. So watch. All these angles, 1, 2, 3, 4, 5 angles in here. Everybody watching? 5 of those angles. So I go 5 minus 3, or sorry, 5 minus 2, which is 3. 3 times 180 is 540. So all 5 of those angles add up to be 540. They're not all equal to 540. That's not 540 degrees, is it? No. But this one, this one, this one, this one, and this one, they all add up to be 540. The sum of the angles is 540 degrees. You with me? David, you getting all this? Okay? You still with me? That cold little field trip didn't wake you up? Look at this right here. Let's do it one more time. So 6 sides. So what do you do? 6 minus 4 is, or 6 minus 2 is 4. Keep doing that. So it's what? 4 times 180. And that's 720. Is that right? Okay. So 720 degrees. What does that mean? It means all 6 of these angles all add up, right? The sum of the angles, they all add up to be 720 degrees, right? What if I had, what if I didn't draw a picture right here? What if I said there were, I don't know, 17 sides, okay? So it's a weird looking, there's really no special name for it or anything else, okay? There's 17 sides, and I want you to find the sum of the interior angles. Okay, Matt, what would you do?
Well, first you'd have to find out how many triangles there were.
And how would you do that?
You would do 17 minus 2.
Right. You would
which
do this
equal
thing right here,
15.
wouldn't you?
Yep.
Okay.
And then you would do 15.
So let's do that. 17
Okay.
minus 2, and that'll be 15. And then what do you do with that?
Then you do 15 multiplied by 180.
Right.
And you get the sum of the interior.
And there you go. Okay. I don't know. I don't know what that is off the top of my head. Somebody do that for me. 15 times 180. What's that? Who's got a calculator? Quick. 15 times 180.
2,700.
2,700. So like that. Look at that. 2,700 degrees altogether. Does that mean each individual angle is that? Of course not. There's no way. But they all add up to 2,700 degrees. Does that mean all the angles are equal to each other? I put little arcs on here, but that didn't mean that they're all equal to each other. Okay, I just was pointing out the angles. Does not mean that all the angles are exactly the same. All right, but they do all add up to 2,700 degrees. Make sense? Okay, so let's go back to this. What is the formula then? There's a little formula, it's a theorem actually. The sum of the interior angles is equal to,
That's what it's called.
what is it?
It's called the sum of the
I don't know, it's called something. They call it the polygon interior angle sum. All right, I don't care if you remember that name or not. Just want you to know how to do this. How do you find the sum of the interior angles? You take n minus 2, n representing the number of sides you have, right? And then do what to it? Times it by 180. Once you do that, you've got the sum of all the interior angles. It's very easy. Okay? But I wanted you to see where that came from. I could have just sat here and said, okay, this is how you find what all the angles add up to be. And you'd probably think, well, why is it minus 2? Why'd you do that? I kind of like that, don't you?
Yeah.
Figuring out where it came from. Okay, so that's what we're doing there. All right, let's talk about another little topic. Let's get rid of all this mess. Okay, I've got this thing right here. 1, 2, 3, 4, 5, 6 sides. Now, this one right here, it's a little bit more special, okay, than the other ones, the other hexagon that I drew. Because what does it look like might be true about these sides. Right. Does it look like a stop sign?
No.
You sure it does?
No, stop signs are
Right, stop signs are octagons, they're 8 sides.
This is a
But watch. 1, 2, 3, 4, 5, 6. There's 6 sides, okay? Let's please listen. Alright, so I've got all the sides are equal to each other. Now, because all the sides are equal, does that automatically make all the angles equal?
Yes.
Not necessarily. It does not, okay? I'm not sure if I can show that on here, but we're not going to worry. Just take my word for it. Just because all the sides are equal does not mean all the angles are going to be equal. But what if I told you that all the angles are equal? What if I said all 6 of these angles are exactly the same? Now, we've done this word before, and yeah, I heard somebody say it. It's a regular, right? In this case, it's regular what?
regular.
Hexagon.
It's a hexagon, right? It's a regular hexagon. Or you could just say polygon if you wanted to, okay? And that polygon could represent any number of sides. But right now we've got 6, so that's a regular hexagon. Now watch. It's we can find now each individual angle if I know that they're all equal to each other, right? Let's find the sum of them. Let's find the sum. What is it? It's 6 minus 2, right? Times 180. So that's 4 times 180, which is 720 degrees. Now, if I told you that all the angles were exactly the same, then what would you do?
720 divided by 6.
That's right. You divide it by how many angles you have. If you have 6 sides, that means you're going to have 6 angles. So if I divide that by 6, what's that?
120.
It's 120. So this angle right there is 120. In fact, since all the angles are exactly the same, they're all 120. Okay, so you're going to, listen please, don't comment, just listen. If you're going to have a problem that says find each interior angle. That's different than finding the sum of the interior angles. If I said find the sum of the interior angles, what would your answer be on this problem?
720.
It'd be 720. If I told you to find each of the interior angles, you would tell me 120. Does that make sense? Okay, so that's when it's a regular polygon, when all the sides are equal and all the angles are equal to each other. Make sense? Okay, let's stop this video and go on to the next one, and we'll do one more topic, okay?